Hello, this is Mr. Stansbury. I'm going to take you through the 12D assignment. Okay, so we'll start here with number 1 for the geometric sequence with the first two terms given. Find B and C. So really all we need to do is figure out what the rate is that we're multiplying by here. So let's take 6 and divide it by 2, right? We take this divided by this, and we get 3. So we figure out that we're multiplying by 3 each time, right? So then we go 6 times 3 is 18, so that's what B is. And then for C, we go 18 times 3, and that's going to give us 18 times 3, and that gives us 54. So that's what C is going to equal. Okay? All right, for B, 5 divided by 10 is 0.5, or a half. So we're just multiplying by a half here. So you take 5 times 0.5, and that gives us 2.5. So that's what B is. And then to figure out what C is, we take 2.5, multiply that by 0.5, and that's going to give us 1.25. So C is 1.25. Okay? For C, negative 6 over 12 is negative 0.5. So to find B, we do negative 6 times negative 0.5, which gives us a positive 3. So B is 3. And then to find C, we take 3 times negative 0.5, and that gives us negative 1.5. Okay? Okay, moving on to the next one. We got number 2. Show that the sequence is geometric first off. So to show that it's geometric, we just we'll take 10 divided by 5, and that gives us 2. And we have to show several. It's ideal to show 3, so 3 different rates that they're all the same. So then we do 20 divided by 10 is also 2, and 40 divided by 20 is also 2. So we've shown that that's geometric because we're getting the same rate each time. So part B, find u sub n, and hence find the 15th term. So we'll find the general term, which is, there's our general term formula. So u sub n is going to equal our first term, which we know is 5 here, times our rate, which we just figured out is 2. And then we have that all to the n minus 1. So there's our u sub n formula, and to find the 15th term, we just plug in 15 for n, right? So u sub 15 is going to be 5 times 2 to the 15 minus 1, right? So, oops, wrong thing there. Let's pull up our calculator. There we go. So we're going to do 5 times 2, and we'll go to the, and it's probably easiest to do just do 15 minus 1 in your head, so we'll do to the 14th power, push equals, and we get 81,920. Okay, so that's the 15th term. Okay, moving on. Number 3, show that the sequence is geometric. So we'll do negative 6 over 12 is negative 0.5. Right, there's the first one. The second one is going to be 3 divided by negative 6, which is also negative 0.5. And then negative 1.5 divided by 3 gives us again negative 0.5. So we've shown that it's geometric. Okay, part B says find u sub n and then find the 13th term. So part B, here's our u sub n formula. So we got u sub n is the u sub 1, which is our first term, which is 12, times the rate, which is negative 0.5, all to the n minus 1. Okay, so now they're asking us to figure out what the 13th term is. So now that n is going to be 13. So let's put that in there. So 13 minus 1. Okay, so we will do 12 times, we don't even have to do that. Let's just do 12 parentheses, negative 0.5. Close those parentheses, and then take it to the 13 minus 1 is 12th power. Okay, and we get 0.0029. Okay, and they said they want it as a fraction. I'm fine if you just leave it as a decimal. It's just it's a lot simpler that way. Okay, so we'll go with that, and we still understand how to do it, so that's good. All right, moving on to number 4. Show that it's geometric, and then find the 10th term. Okay, so show that it's geometric. Negative 6 over 8 gives us negative 0.75. 4.5 over negative 6 also gives us negative 0.75. And then negative 3.375 over 4.5 should give us negative 0.75. Let's just double check. Let's see. So we got negative 3.375 divided by 4.5. And indeed gives us negative 0.75. So we've shown that it's geometric. And then now it says find the 10th term as a decimal. So what we're going to want to do is we're going to want to make sure that we plug it in. We want to use our formula here to figure out the 10th term. Okay. All right. So we've got u sub n equals u sub 1, which is the first term, which is 8. And then our rate is negative 0.75. Right. And then we're looking for the 10th term, so that's to the 10 minus 1. So on our calculator, we're just going to do 8 times, let's see, again, we don't even have to do the times, but we'll just leave it in there, times negative 0.75, and then we're going to take that to the 10 minus 1 is 9 to the 9th power, and that gives us negative negative 0.600. Negative 0.6006, I think is what it was, right? Officially, if we round that thing, it would actually be 7. So let's put that in there. Okay. Okay. Moving along here. Find k, given the following are consecutive terms of a geometric sequence. So if they're geometric, to figure out what these are, remember we got to take the second term, divide by the first term. So we know that k over 7 should be the same as 28 divided by k. So equals 28 divided by k. Because remember, any two consecutive terms, they should always have the same rate. So k divided by 7 should equal 28 divided by k. Now that we have this, we're just going to cross multiply, right? So we got k times k is k squared, and that's going to equal 7 times 28. Okay, so 7 times 28, and that gives us 196. Okay, so now to figure out what k is, we just square root. So we get k equals, so let's square root this thing here. So we do second square root, second answer, and then you don't even have to enter the 196 in. And that gives us 14. Now officially it should be plus or minus 14, right? Because if we did, so the k could be positive 14 if we multiplied this by 2, right? So 7 times 2 is 14, 14 times 2 is 28, or it could even be negative 14. 7 times negative 2 is negative 14, and negative 14 times negative 2 is back to positive 28. So k could be either 14 or negative 14. Okay. For b, 3k over k, this divided by this should equal 20 minus k over 3k. Okay, and then we're going to cross multiply. So we get 3k times 3k is 9k squared, and that's going to equal these two multiplied together, and that's k times 20 minus k. So we get 9k squared equals k times 20 is 20k, and then k times negative k is k squared, right? So I'm going to just move all these to one side. So I'm going to add a k squared and subtract a 20k. So we get 9k squared minus, oh, sorry, not 9k squared, because we added a k squared. There we go, plus k squared minus 20k, right? That's not helpful. There we go. So 9k squared plus k squared is 10k squared, and then we have minus 20k equals 0. Okay, so on this here, we could factor a 10 and a k out of both of these. All right. So if we take 10k squared divided by 10k, we're left with a k, and then negative 20k divided by 10k is minus 2. So k can either equal, let's see, 10 times 0 gives us 0, or 2 minus 2 gives us 0. So it could be 0 or 2. Now we want to double check those to make sure that they work. If we plug 0 in, we get, for 0, if we plug in 0, we get 0. And then 3 times 0 is 0. And then the third one is 20 minus 0, which is 20. This is not a geometric sequence. You can't multiply 0. Well, anything you multiply 0 by, you get to 0. But there's nothing you can multiply 0 by to get to 20. So this k here does not work. Let's try 2 and see if 2 works. If you plug in 2, that gives us 2. 3 times 2 is 6. And 20 minus 2 is 18. If you check this one here, that's 2 times 3, right, is 6. And then 6 times 3 is 18. So 2 does work. Okay? All right. For C, we're going to do k plus 8 over k, and that should equal 9k over k plus 8. Okay, so cross multiply. 9k times k is 9k squared, and that's going to equal k plus 8 times k plus 8. Okay, so we get 9k squared, and we got to FOIL this thing out, right? So k times k is k squared. K times 8 is 8k. 8 times k is 8k. And 8 times 8 is 64. Okay? So we've got everything here. Let's see. Let's add these two together here to get 16k. So we got k squared, plus 16k plus 64 all equals 9k squared. So again, we're going to want to pull everything, move everything to one side. K squared is our highest power here, so I'm going to move everything to the left so that we keep our k squareds positive. So I'm going to subtract k squared, subtract 16k, and subtract 64 from both sides. Minus k, minus 16k, k squared, and minus 64 here. That was a bad shot. There we go. These all go away, so we end up getting 0. And they have 9k minus k is 8k squared. I'm sorry, 9k squared minus k squared is 8k squared. And we have minus 16k and then minus 64. Okay, now we're going to need to factor this. The nice part about this is all of these have a factor of 8 in them. So let's divide everything by 8. And we get k squared minus 2k minus 8 equals 0. So now we can factor this out. K times k is going to give us our k squared. The factors of 8 that have a difference of 2 are 2 and 4. Right? And then I got to put the signs in here so that these two, the 2 and the 4, add up to negative 2. So it'd have to be positive 2 and negative 4 gives us negative 2. And positive 2 times negative 4 gives us negative 8. So k can either equal negative 2 or positive 4. Okay, let's double check to make sure that these work. So if we get k equals negative 2, we would get, so if we get negative 2, we're going to get, let's see, negative 2, and then negative 2 plus 8 is 6, and then 9 times negative 2 is negative 18. So that works because that's negative 2 times negative 3 gives us 6. 6 times negative 3 gives us negative 18. So that works. Let's try 4. We get 4 for the first term, and then 4 plus 8 is 12, and then 9 times 4 is 36. So let's see. If you can't figure out what that is, well, that's times 3, right? Times 3. We could always do 12 divided by 4 gives us 3. And then 36 divided by 12 also gives us 3. So both of these work. Okay? All right. Moving on to number 7. Find the general term of the geometric sequence, which has u sub 4 is 24 and u sub 7 is 192. So on these here, I really like to make these little chart thingies. So let's do this. And a little table. Oh man, I'm having a hard time making straight lines here. That's good enough. So we got 1, 2, 3, 4, 5, 6, and 7. We want to get up to the highest number there. All right, so make our little table here, and we know that the 4th term is 24. We know that the 7th term is 192. Okay, so what we like to do here, and again, if you don't like this way, the book shows it a very different way. You're welcome to try whichever one works best for you. I like this way best, so I'm going to go with this. So 24, we know we have to take 24, multiply it by the rate once, so multiply by the rate to get to this number. Multiply by the rate again to get to this number, and then multiply by the rate one more time to get out here to 192. So what we say is, okay, if we have 24 and we multiply it by 1r times r times r, which is r cubed, it should and will give us 192. Okay, so we want to figure out what r is, so we divide both sides by 24. All right, and we get that r cubed is, let's see, we take 192 and divide it by 24, and we get 8. Okay, so to figure out what r is, we have to get rid of the cube, so we cube root both sides, and that's going to give us that r is 2. Okay, so we now know that we're multiplying by 2 each time when we go to the right. Okay, so in order to figure out our general term, we need the u sub 1, which is this term here, and we need the rate. So we found the rate. Now we just have to find the u sub 1, and then we're good to go. So to the right, if we're moving to the right, we multiply by 2. Hopefully it would make sense if we're going to go back the opposite direction. We're going to actually divide by 2. For each one of these, we'll divide by 2 each time. Okay, so if we take 24 and divide it by 2, that gives us 12. 12 divided by 2 is 6. 6 divided by 2 is 3. So our first term now we know is 3. So we've got our formula. U sub n equals, the first term is 3, and then our rate is 2 to the n minus 1. And there's our general term formula for A. Okay, for B, we're going to do the same thing. We need 3 and 6. So we'll do n, and we'll do 1, 2, 3, 4, 5, and 6 is as far as we need to go. Okay, we know that the third term is 8 and the sixth term is negative 1. So just like what we did on A, we're going to say we multiply it by the rate 1, 2, 3 times here. So we take 8, and if we multiply it by r times r times r, which is r cubed, that should give us -1. Okay, so we want to divide both sides by 8, and we get that r cubed is -1/8. So to figure out what r is, we got to cube root both sides here, and we get that r equals, so probably the easiest way to do this particular one is just take the cube root of -1, which is -1, and then the cube root of 8 is 2. So our rate is -1/2. Okay, so going to the right here, we're multiplying by 0.5. Okay, so we've got the rate. Now we just need the use of 1. So if we're multiplying by 0.5 this way, -0.5. If we're going back this way, we're dividing by -0.5. And if you're dividing by 1/2, that's the same thing as, you can flip it over and switch the sign. So, sorry, -1/2. So, you don't have to switch sign. Sorry, just multiply, just flip it over. So we are, instead of dividing by 1/2, we are multiplying by -2/1. So let's put this here, dot. So we're multiplying by -2 going back this way. So multiply by -2 to go to the left. 8 times -2 is -16. -16 times, -2. There's a negative in there. Gives us 32. So our first term is 32. So our use of n equals 32 times, our rate is -0.5 or -1/2, whichever one you want, all to the n minus 1. Okay, let's look at C then. So U3 to U6. So we're going to do the same thing, n, and we just need to go up to 6. 1, 2, 3, 4, 5, and 6. Okay. So let's see. We know the third term is 8, and oh, sorry, that's the wrong one. We got 7 up to 15. Let's back up here for a second. Okay, here's our chart because we got to go from 7 out to 15. So our 7th term here is 24, and our 15th term is 384. Okay, so to get from here to here, we need 1, 2, 3, 4, 5, 6, 7, 8 rates. So we're starting with 24, and we multiply it by the rate 8 times, should give us 384. Okay, so let's divide both sides by 24, right, and see what we get. So we've got 384 divided by 24, and we get 16. Okay, so we get r to the 8th equals 16. So we got to take the 8th root of both sides here to get what r equals. So let's take, we got to take the 8th root of 16. So we're going to do 8 second root right here. So that's the 8th root of our answer. So 8th root of 16 gives us 1.41, which happens to be the square root of 2. Okay, so we are multiplying by the square root of 2 each time going this way. So if we're going back this way, we got to divide by square root 2 each time to go back here to get to the first term. So that's 24. We got 1, 2, 3, 4, 5, 6 times. So we got to take 24 and we got to divide by the square root of 2 6 times. Okay, so let's see if we can figure that one out. So we've got, there's our square root of 2. It's already in there. So let's do, we got 24 divided by, let's do parentheses, our answer to the 6th power. Oops, let's see. Let's see if we can get this to work right. There we go. So we're taking 24 and we're dividing it by 1.416 times just to see what we get. And we happen to get 3. Okay, so then that means we get u sub n equals the first term, which is 3, all times the rate, which is square root of 2, all to the n minus 1 power. Okay, so that would be what C is. All right, moving on to the last problem here. We've got number 8. Find the first term of the sequence, which is this, which exceeds 10,000. So for A, first thing we're going to want to do is figure out what the general term formula is for this here. So if it's geometric, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So we know our general term formula is going to be first term, which is 2, all times the rate, which we just figured out is 3, to the n minus 1. Okay, so that's the general formula for this here. So we want to figure out what term is going to exceed 10,000. So let's just do this. Let's just say, so we want to know when this here is going to be more than 10,000. So let's just set it equal to 10,000. 2 times 3 to the n minus 1, and then we got to figure out what term is going to make this true. Okay, so we want to get this n minus 1 all by itself. So the first thing you need to do is divide both sides by 2. So we get 5,000 equals 3 to the n minus 1. Now, on this here, once you find that you've got your variable is an exponent, we need to use logarithms, right? So we get log 5,000 equals log 3 to the n minus 1. Okay? Now, this n minus 1 can now come out front here, right? So we've got log 5,000 equals n minus 1 all to the log 3. We want to get n minus 1 by itself, so we divide by log 3, both sides. And we end up with n minus 1 equals, let's see, log 5,000 divided by log 3. Let's figure that out. So we've got log 5,000, which is 3.69. Divide that by log of 3, and we get 7.75. Equals n minus 1. So we don't want n minus 1, we want just plain old n, so let's add 1 to both sides. And we get that n equals 8.75. So there's obviously no such thing as the 8.75 term. So we want to make sure that this thing here is going to be bigger than 10,000. So we'd want to go to the bigger term since this is a positive number. Well, since this number is greater than 1, that means this thing's growing. So that means our n should be 9. Okay, let's double check to make sure that we're good. So we're going to do 2 times 3 to the, and if we plug in 9, that's 9 minus 1, so that's to the 8th power. And this should be a number that's bigger than 10,000. And it is. It's 13,122. So then we know that this n equals 9 is correct. Okay. Let's take a look at C then, first term of this sequence. So let's see, 6 over 12 is 0.5, 3 over 6 is also 0.5, and 1.5 over 3 is 0.5. So there's our rate, 0.5. And we have our first term. So let's write our general term formula. So we have u sub n equals, our first term is 12 times 0.5 all to the n minus 1. There's our general term formula. Okay. Now we want to figure out which term is going to, what's the first term in the sequence that's going to be less than 0.0001. So let's do this. 0.0001. When's that going to equal 12 times 0.5 to the n minus 1, right? First step, divide by 12 to get rid of that there. So we got divide by 12 here. And let's bring this over here so we can see it. So we've got 0.0001 divided by 12, and we get 0.123456860. So no, sorry, 5. 1, 2, 3, 4, 5. 0.000083 repeating equals n. Oops. Let's see here. There we go. 0.5 to the n minus 1, right? So again, on this one here, we got to do logarithms, just like we did in A. Now, a little bit of a shortcut to logarithms is, instead of having to go through this whole process here, whatever your exponent is, so there's your n minus 1, I know that this piece here wants to be in this spot here, so I kind of think of this. I think of this n minus 1 moves into this spot where the 0.5 is, and the 0.5 gets pushed down and underneath here, so it's going to end up being log of 0.00000083 repeating all over log of 0.5, and that's going to equal n minus 1. Okay, so I will take the log of my answer there. It gives me negative 5.07, and then I'm going to divide that by the log of 0.5, and that gives me 16.87 equals n minus 1. So I got to add 1 to both sides. Oops, that's a plus 1. And so that gives me 17.87 is what my n is. Okay. Now, this is not, obviously 17.87 can't be an n because it's got to be a whole number here. So it's got to either be 17 or 18. All right, and whichever I choose, I'm just going to double check it to make sure that it works. So if the term has to be less than 0.001, my guess is that it's going to be 18. So let's check and see if that works. So I'm going to take our formula here, 12 times 0.5 to the 18 minus 1 is 17th power. Oops. So I'm going to take that to the 17th power and see if that works. So in that one there, we get 0.000. This is supposed to be a 1, and it's a 0.9, so this does actually work out there. So it should be n equals 18. Okay. That's all there is for this assignment. If you have any other questions on this, please feel free to ask in class. Thanks.